Got a new topic for the AQA exam question walkthrough. So this is the first one for the acids, bases and pH topic. Hope you like the video, hope you find it helpful, and if you haven't already subscribed to the channel, I'd love you to do so. But as always, the link to the questions in the description of the video if you want to try it first. So make a start. So part one, which is the correct expression for Kw? And the answer obviously is C. Kw equals the H plus concentration multiplied by the OH minus concentration. Moving on to part two, calculate the pH of pure water at 10 degrees C. The important thing to know is that in pure water, the hydrogen ion concentration is equal to the OH minus concentration. So that means we can simplify the Kw expression to the H plus concentration squared. So rearranging for H plus concentration, we get the square root of Kw, and then all we need to do is sub in the value they gave us at the top of the question for Kw at 10 degrees C. So that means the H plus concentration comes out at 5.412 times 10 to the minus 8. All we need to do now is minus log that to get the pH, which to two decimal places is 7.27. Moving on to number three, we've actually already answered this question in part two. So in pure water, remember the H plus concentration is equal to the OH minus concentration. That's why it's not alkaline, even though the pH is above 7, it's actually neutral. Moving on to number four, we've got to calculate the pH of this concentration of calcium hydroxide solution. Again, it's at 10 degrees C. So you can see I've written up the dissociation equation for calcium hydroxide. So if the concentration of the calcium hydroxide is 0.0131, the hydroxide ion concentration will be double that, so 0.0262. Now we bring in the rearranged Kw expression, rearranged for H plus concentration. So Kw over hydroxide ion concentration. Now we just need to sub in our numbers. Remember the Kw value for 10 degrees C is that. So we divide that by the hydroxide ion concentration and we get that for the H plus concentration, which we just need to minus log for the pH, which to two decimal places is 12.95. And finally part five, just got a little bit of group 2 there to help me explain this one. So the thing to note about the group 2 hydroxides is they get more soluble as you go down the group. So it's probably more helpful to look at the explanation first. So I'm saying solubility of group 2 hydroxides increases down the group. So therefore magnesium hydroxide, which is higher up the group, is going to be less soluble than calcium hydroxide. That means that the hydroxide ion concentration in a solution of magnesium hydroxide is going to be lower than that for calcium hydroxide, and therefore its pH will be lower as well. It'll be less alkaline.